Here are the notes from Module 12. In Module 12, we continue with similarity, but now we're dealing specifically with similar triangles. So the first property we learned says that if you have in a triangle a line passing through that is parallel to one of the sides, and this triangle line MT is passing through triangle VLU, and MT is parallel to side LU. These two, it's marked on the diagram, but just so that you can see it, those two lines are parallel. Well, what that's saying is that that parallel line breaks up the sides that it touches proportionally. It breaks it up proportionally. So we learned before that a proportion is two equal fractions. So if I were to make a ratio comparing these new segments that are created, let me try to erase these. VM, VT, ML, and TU, I could make a proportion that says that VM over VT is equal to ML over TU. I could also say that VM over ML, if I put these two together, is the same as VT over TU. When you divide them, you'll get two equal ratios, two equal fractions. And this last conjecture here just says that if I had more than one parallel line, if I were to throw in another one and another one, all these new small mini segments would still be proportional. You know, VM, and then this one here that's not named, this next one, this next one. Those I could make a proportion with any one of those smaller segments, as long as all the lines are parallel. Okay. On the next page, we get into geometric means theorem. So what this says is if I have a right triangle, it has to be a right triangle. Here on the diagram, I have a right triangle, and I draw the altitude that goes to the hypotenuse. And altitude is a segment that goes from one angle to the opposite side at 90 degrees, but now that side would have to be the hypotenuse. Okay, if I draw an altitude, how can I say this? That height, that altitude, is equal to the geometric mean of the new segments that are created. What geometric mean is you take the square root of a product. Here they have that written as square root of x and y. So this tells you if I draw the altitude, and this altitude now breaks up this hypotenuse into a smaller segment here called x, and one that's a little bit bigger called y. If I multiply that x times y and take a square root, that will give me the length of the height. That's the first geometric means theorem. The second one says that if I draw the same thing, if I draw an altitude that breaks up the hypotenuse into two smaller segments, the legs of the right triangle, here's one leg A and here's one leg B, those legs can be found by finding the geometric mean of with the entire hypotenuse and with the shorter segment. So like for instance, if I wanted to find A is a leg that is touching this smaller segment X. So if I wanted to find A, it would be the X times the entire hypotenuse and then the square root. If I wanted to find B, which is a leg, B is touching this smaller part of the hypotenuse, that's Y, so I would multiply Y times the entire hypotenuse, and that would give me B.